Okay, good morning. Good evening, everybody. If you can hear me fine, could you please type in a yes in our chat window, guys? Thank you. Thank you, guys. So I'm also sharing my screen. Hopefully, you're also able to look at the screen, guys. So let us get started for today. And before we get started, a quick and a friend from yesterday, guys. We briefly, before let me just go ahead and bring up the video here. Hope you can all see my face today. I just want to say good evening to everybody and welcome. And it looks like yesterday I shared my email and a bunch of you guys have requested me. We're asking one question, guys. There was one question which was coming up a lot, which is, if you do not have any programming or Python programming, can you get into the world of AI, is what a lot of guys were asking me. So in other words, it is not a must to have programming background, but Python is a kind of a must, guys. Okay, or in other words, I'll admit it, Python is a must. So in other words, generally there are a lot of institutes who offer Python for free. You can join. The Naresh IT itself has offering a free course. You can also join that. Here I will a little bit of Python, but due to time constraints, I cannot go much into of it, guys. But if you are able to pick up a little bit on your own also, that is good enough. With a little bit of Python, you can do a lot of magic in artificial intelligence, machine learning, and deep learning, guys, if you have a basic idea of object-oriented programming, guys. So because a lot of guys sent me mails, I just wanted to address that first so that I don't forget it. With that, I will turn off the video so that we can save a little bit of bandwidth and the screen is a little bit more clear, guys. Okay. So I think what we discussed about a little bit about hypothesis testing, and we'll talk a little bit more about it today. Hypothesis is about making assumptions and trying to prove them, trying to understand if it is something is random or if something is truly occurring is what is hypothesis testing, guys. These are the different kinds of assumptions in a general world. These are the different kinds of assumptions in a business world. Then we briefly talked about confidence interval. So what is confidence interval, guys? Imagine Prasad. Prasad is a common man. And let's say Mahi. We have Mahi and Prasad here, a couple of the attendees. Imagine Mahi is a fan of cricket. He goes to Prasad and asks Prasad, hey buddy, what do you think? Imagine there is a match tomorrow. And there you go, guys. That is my email. Thank you, guys. There is a cricket match tomorrow. So Mahi is asking Prasad, what do you think Sachin is going to score? Maybe Virat is going to score. As a common man, Prasad may say he might score 50 runs. But imagine Chandana. Chandana is another attendee. Imagine she is also a statistician. Generally, what do statisticians do? They don't give a single number. They will give a range. Imagine Chandana is now saying, hey, I'm kind of predicting he's going to score somewhere between 40 and 60 runs. That range is often, in a simple way, referred as a confidence interval. Okay, guys, some of you were asking what is confidence interval and things like that, so I thought I'll just bring up real quick, guys. But let's make a little bit progress. Today also I will focus a little bit on the theory, guys. Starting from tomorrow, probably I'll give it a touch of the Python. So just allow me to cover a few concepts in theory, and we'll try to make some progress in programming also, starting from tomorrow. In the meantime, if you have a little bit of time, try to just do a little bit of read up on basics of Python for tomorrow. So just some basics are enough, guys. I'll, however, quickly go over them, but just in a friendly way, I'm going to request you to do that. So now here, we're going to dig a little bit deep into hypothesis testing, guys. Let us see, what do we have here? So the process of hypothesis testing in a statistical world, this is called statistical thinking. In a world of data, in the world of data science, artificial intelligence, machine learning, we do a lot of statistical thinking, guys. So we should try to learn what is statistical thinking. So the first step is state the null hypothesis. We have not really talked about what is null hypothesis yet. We have not talked about what is alternate hypothesis yet. Okay, null hypothesis is always status quo, which means no difference. The keyword no difference is a big word in the world of statistical. In the world of statistics, generally, is there a difference or is there no difference is generally being talked about. So in other words, let us say, let's see if I can give you an example, guys. Imagine here is a coffee shop. And in the coffee shop, let us say, choose this one. Let's say, choose this one. Now choose this one. No, it doesn't allow me. Let's choose this one. On a hot and a warm, oops, not this one. Let's come back here. Choose this. Choose this. On a hot and a warm day, when it is temperature is hot and warm, what's happening is lots of people. So let's say, here's lots of people are coming to the coffee shop. They're sitting, they're having tea, coffee, and as a result of that, the sales is increasing. The sales is high. Okay, on a hot and a warm day. But let's say, choose this one. Let's choose this one. And here is, let's say, how shall we put this? How about, let's say, take a look at this one. Here is a cold day. On another day, when the temperature is cold, so I'll try to put it here. How about this one? When the temperature is cold, what is happening is, people are not moving out. If you're in Hyderabad today, it is pretty cold here, guys. It is getting pretty cold and things like that. You're probably reading in the newspapers and things like that. What is happening? The sales is down. Why? People are not moving out of their home. So what can we say? We can roughly translate this and choose this one. We can translate this and say, when the temperature is high, what's happening? The sales is high. But when the temperature, when it is cold, the temperature is low, the sales is also low. So, is temperature impacting sales? Is temperature making a difference on sales? Or in other words, more precisely, it should be the reverse. Can we say, is sales dependent on temperature? Is there a difference? Is temperature, the change in temperature, is it impacting the sales or not, is what we can try to analyze statistically. Okay, as the temperature is changing, is there a difference it is causing on the sales? What is that? That is where a keyword called no difference is coming up. This is called a statistical thinking, guys. We generally do this a lot in the world of data. And data is either used to reject or not reject the null hypothesis. What is this? This is the language of statisticians. Statisticians always take scenarios like this and they try to translate it into something like this. They translate it into hypothesis testing. Then they translate it into null hypothesis. Then they translate it into alternate hypothesis. Then they say they either reject or they do not reject. They never say they accept. This is the language of a statistician. In other words, if you go into the world of cricket, you're always talking in terms of batting, bowling, runs and wickets. That is the language of a cricketer. Go into the world of badminton, you're talking in terms of racket, shuttle, do the service, do the smash, how many points you have, and things like that. That is the language of badminton. This is the language of statistician. Hypothesis testing is one of the important concepts, guys. So what do we do? Well, ideally, we will see if we can talk a little bit more about this one in the coming up slides, guys. But let's go to step 2. You try to identify a test, an appropriate test statistic that can be used to assess the truth of the null hypothesis. So somehow we'll try to understand whether we need to reject or not. What does that mean? We'll have to wait a few more days to understand that, guys. So in other words, we'll try to identify a test, and what is it? There is something called a Z test or a T test. Then what do? Step 3, compute the p-value. P-value in a friendly way is nothing but the percentage of the error. It indicates a strong evidence against the null hypothesis, against that is the language of a statistician, guys. So what we also need to understand is what is this p-value. We'll also try and to understand and attempt to understand that in coming up ones. So compare the p-value to an acceptable significance level. Significance value, the global industry standard is 0.05. In other words, that is nothing but 5%. That is the global industry standard. So ideally, what we do is we take the data, a statistician. So let me do a little bit of cleanup here so that I can clear the mess a little bit. Statistician will take the data and imagine, let's choose, how about this one. Here's a function. We are taking the data. Let's say we'll take this one. Here's the data. What do we do? A statistician will take the data and he will give it to a function. The function will internally take the data and will calculate the p-value. If the p-value is less than 0.05, which is the global industry standard, we reject the null hypothesis. What is this? At this stage, it is probably not only tough, but it is probably very tough for you to understand what these terms mean and things like that, guys. Okay, so these things we'll try to simplify in the coming up days and things like that. So before I proceed, just give me a quick yes, guys. Okay, I don't expect you to understand that slide very well, but I'm just getting you familiar with a little bit of terminology there. So let's move a little ahead. Let's see what is happening, guys. So here is null hypothesis. Let's apply the language, the terminology of statistics in the judicial world. And let's see what is happening here. There you go. So here is null hypothesis, which says person is innocent. And here is what we have. We are calling this as a true state. Here is what is the decision which was made by a judge. Imagine a person is innocent. And a person is innocent. But what happened? Well, imagine he was sent to a prison. What is that? That's an error. In a real world, that's an error. That's not a good decision. Sending an innocent person to a prison is not a good decision. That's a bad decision. That's a mistake. In a statistical world, we call that as a type 1 error. Then, if somebody is innocent, let's take an innocent guy. Let's choose this one. Here is a guy who's innocent, and what happened? He was set free. You set free an innocent guy. What is that? That's a correct decision. There's nothing wrong in it. Then take another scenario. Here is somebody who's guilty, and what happened? Well, he was sent to prison. What is that? That is also a correct decision. No problem there. But let's say you take a guilty guy, and what are we doing? You're setting him free. What's that? That's an error. That is not a good decision. That is a mistake. So, putting it in simple terms, a mistake is what we are calling as an error. Now, here is, if you look at type 1 error and type 2 error, guys, do you think it is more dangerous to send an innocent person to prison or sending a guilty person, setting him free? Among type 1 error and type 2 error, which one do you think is more dangerous, guys? A lot of type 2s. If you send an innocent person to prison, because he is innocent, he is probably a good guy, he goes to prison, he is behaving himself and is good. But imagine a guilty guy is set free. What will he do? Well, he's going around your colony, and there are chances that he might create more problems and things like that. So, in a statistical world, based on domain to domain, certain times type 2 error is more dangerous, certain times type 1 error is more dangerous, is what it means, guys. So, let's see if we can translate this one into null hypothesis. This is a tough one, guys, but I'll just give a quick attempt here and see if I can try to convey my message and convince you. Person is innocent means person is innocent. What we need to do ideally is we need to translate this into what is called no difference. That's a tough one, guys. For me, that's a tough one, but I'm just giving a thought. Okay, you'll have to forgive me. You'll have to pardon me. I will come back to that, and I'll see if I can explain that in another way, guys. Okay, so give me just a quick yes on this slide, guys. So here we just try to understand, hey, There are sometimes mistakes can happen. The mistakes are generally referred as errors. In the errors, there are two kinds of errors, type 1 error and type 2 error. In certain domains, type 2 error is more dangerous. In certain domains, type 1 error is more dangerous. It's a quick thing, guys. Let's move one step ahead. Okay, so we're still sticking to the language of hypothesis testing. This is the world of statistics, guys. It is always reject or do not reject. Statisticians always go by reject. Oops, not this one. We'll choose this one. They say they reject the null hypothesis, or they say they do not reject. They never say they accept the null hypothesis. Their languages, they say they do not reject the null hypothesis, guys. Rejecting the null hypothesis means there is evidence that there is a difference. And if I really need to explain this one, again, I will need to wait maybe a few days to give you an example, guys. I did not come up with an example right away, but I kept it for the coming up days. But imagine I'm just getting you familiar. What is this one? This is saying rejecting the null hypothesis. This is what we'll try to understand in the coming up days. Failure to reject the null hypothesis, which is the opposite of this one, okay, means that the data is insufficient to conclude that there is a difference. Okay, the word there is a difference, there is a no difference is a big thing in the world of statistics, guys. And okay, so let's come back to the basics. Let me come here. See if we can simplify this. What is a hypothesis? A hypothesis is an assumption. In general, in a real world, what we are assuming, go to a business world, lots of assumptions are being made by the top level management guys and lots of business analysts and things like that. They're thinking a lot of things and they're coming up. What do we call them? We call them their hypothesis. What do? That's where the data scientists come to their rescue. They go to the data scientists and they're asking them, guys, you know, we're thinking our sales is increasing. The sales of a coffee shop is increasing because of temperature. Is there any way you can validate that? Is there any way you can verify that? Is what they will ask their data team, their data analytics team. That's where the data scientists jump into the picture and they try to prove it and they try to give them meaningful explanations and things like that. Those are things we'll try to understand. So hypothesis is an assumption which we make about a population parameter. Okay, in the world of statistics, generally what happens, guys, there are certain terms I will force you to remember. A population parameter is generally a mean or a standard deviation, sigma. Population parameter. What are we saying? Generally imagine a statistician is always, or somebody is always saying, hey, here is the average or here is the standard deviation. They are estimating something, but they are not sure. So what do? Well, they're assuming something. That is what is the hypothesis. That is what their assumption. Hypothesis which we wish to test is called the null hypothesis because it implies that there is no difference. In other words, even if you don't understand, guys, think of the mantra of null hypothesis is no difference. The meaning of null hypothesis is no difference between the true value and the hypothesized value. What is true value? Imagine we are a group of people. Let's say there are 20 people in our group. You take an average of this 20 people. Let's say that's coming to be average salary that's coming to 100,000 rupees, which is 1 lakh rupees. But imagine we took a sample of 5 people and let's say their salary is coming to be 50,000 rupees. What is this? This is what is the sample, and this is sample's average. This is the population average. But imagine Prasad comes in and he says, guys, I think, you know, this group of people are making $25,000 more. This is hypothesized value. The sample. So we'll get rid of this arrow. We'll get rid of this arrow. The hypothesized value is 25. The actual population mean is 100 and the sample mean is 50. So is there a difference? Is there no difference? Is what we will is what hypothesis testing is about at a slightly high level, guys. We go one step ahead. A thesis is something. Understand this one. Let's take a look at this slide. A thesis is something that has been proven to be true, which means a thesis is proven. Hypothesis is something that has not yet been proven. Something which is not proven is hypothesis. So if you prove it, that becomes a thesis. It's like an opposite of hypothesis. Hypothesis testing is a process of determining whether or not a given hypothesis is true. Like, you know, whatever you're thinking. Somebody, a top level guy in a Starbucks coffee shop is saying, guys, tomorrow the weather is looking very hot. The temperature is going to be high. Let's get a lot of inventory and keep it. Is what he's suggesting. He's at a high level management. Now, what is he thinking? He's thinking because the temperature is high, a lot of customers are going to come to the coffee shop. So that is his thinking, that is his assumption, that is his hypothesis. What can we do? Before we make a decision and invest a lot of money in buying the inventory, we can actually verify, go to the data and see if it also tells a similar story, if it can prove it or not. That is where the hypothesis testing comes to rescue. Hypothesis testing along with the estimation, or in other words, hypothesis testing forms the foundation of inferential statistics. That's a slightly advanced level of statistics, guys. So that's a quick touch of it. Everybody okay? Cool. Okay. So let's go one step ahead and let's see what we have here. Measures of central tendency. A few basics of statistics, guys. We'll come back to this one, mean, median, and more. What are they? They're called central tendency measures. Let's see what that means, guys. A measure of central tendency. So let's say, come here. Oops. Put this here. A measure of central tendency is a single value that attempts to describe a set of data. It is a single value. It is describing a set of data by identifying the central position within the data. Which means a simple example is there's a group of 20 or 25 people. Let's say all of them are data scientists. You took their salaries, you took an average, and let's say it's coming to be 100,000 rupees, 1 lakh rupees. What is that? That average is nothing but the mean. Okay, what is mean? Mean is generally at the center. Okay, and the central tendency computes the center around which the data is distributed. Means, in more simple terms, central tendency is describing, it is giving you a picture of the center. Mean is one measure which says, hey, this is the center, this is one way of understanding the center, median is another one, and then mode is another one. Okay, these are some basics. I'm going to take you back to a little bit of school concepts here. So let's see what we have. What is mean, guys? Mean is nothing but the arithmetic mean. And it is the most common mean. Generally, whenever we average, we refer to the arithmetic mean. What do? We have a group of points, you sum them up and you divide by the total, you get this one, x bar. That is referred as a sample mean. Let's go one step ahead. Look at this one. Here is we're taking sum of the values, you divide by the number of the values. So let's say these are called data points. There are 5 data points, 1, 2, 3, 4, 5. What are we doing? You sum them up, you divide by 5, you get 3. That's a mean, which is a simple calculation. But what is the problem? It is affected by the extreme values. Imagine, for the sake of simplicity, let's do a little bit of cleanup. Imagine here is Prasad. Let's say Prasad is making 10,000 rupees a month. Let's say here is Mahi. He's making 50,000 rupees. The rest of the guys are between 10,000 rupees and 50,000 rupees. What's happening? The mean is coming somewhere here. And what is that? That is the center. That's coming to be center. Let's say that is 30,000 rupees. Now, here is another scenario. Back to, let's say, Prasad. Another scenario. Here is Prasad making 10,000 rupees. And now, here comes, let's say, Chandana. What is special about Chandana? She's a $1 million girl. She somehow got into this group of people. Here is Chandana. And here is, let's say, who's the other guy? Mahi. Mahi is at, let's say, 40,000 rupees. Now you try to take an average. What is happening is, the average is coming, the middle is ending up coming here. This is like 4. But more precisely, imagine this is $1 million. What will happen is, the mean will be somewhere between 10,000 rupees and $1 million. The mean will be somewhere at $500,000. Now, what is happening? Majority of the people are between 10,000 rupees to 40,000 rupees. Their salary is 10,000 rupees to 40,000 or maybe 50,000 rupees. But because of one girl, Chandana, who's making $1 million, we're getting the average as $500,000. So now, if we go outside to a business and this is a group of people who is making $500,000. What will happen, guys? Well, some wrong decisions, incorrect decisions could be made. If you know a group of people's salary average is around, let's say 50,000 rupees, what can you sell them? You can probably sell them a car, maybe sell them a Honda, maybe sell them a Toyota car, or maybe some other cars you can sell them and you ask them to pay the EMIs. But if you tell here is a group of people who's making $500,000, you can sell Honda or Toyota, but more precisely, you can sell them a much bigger car, which is like, say, Ferrari. And what happens if you sell Ferrari to this group of people, where the majority of the guys are only making from 10,000 to 40,000 or 50,000 is, none of them will be able to buy. So what is happening? Just because of one person, we're getting a wrong picture. What is that? That is what is the problem with mean. Mean is affected by the extreme values. Even if it is only one value, what will happen? It will give you a wrong picture. It is called an outlier. It is called an extreme value in a slightly simpler term. Everybody with me, guys? Quick yes, please. Okay, so we're going a little bit into depth of a few statistical concepts here. So now take a look at this, guys. The solution. Here is a solution for that. Let's see if we can simplify this one. Here we go. The hotshot sales executive. What's happening? Kurt works as a sales manager at sellhomes.com. Imagine that's a website, that's a company. In the monthly sales review, Kurt reports that he will achieve his quarterly target of $1 million. So he's sitting in a meeting with his team and he's saying, hey guys, I'm going to meet a target of $1 million is what he's saying or suggesting. Kurt claims his average deal size is $100,000. So what is he referring? More precisely, he's calculating the average. He's saying, guys, I got an average of $100,000. And what does he have? He has 10 deals. So if all the 10 deals will work out, that will be a $1 million. That's what he's thinking. So there is his boss. Kurt's boss is Ross. He's very delighted. He's very happy with his numbers. But at the end of the quarter, even after closing 8, if you close 8, which is each one is 100,000, what is happening? There should be 800,000. Kurt fails to meet his target by $500,000. Okay, so what does that mean? Let's go one step ahead. We want to understand why did Kurt fail. With 10 deals in his pipeline and an average deal size of 100,000 and converting 7 or maybe 8 of them, how did he fail is what we want to understand, guys. So what's happening? Here is what is happening. Come here and choose this one. So average deal size, average is mean, arithmetic mean is 100,000 and deal number 10 is significantly higher. So take a look at this. This is $500,000. The rest of them are going anywhere from, the minimum is let's say 50,000 rupees to let's say the maximum is 70,000. Majority of them, about 9 of them are between 50,000 to 70,000. Only one of them is $500,000. This is like our Chandana's salary, who's making $500,000. She's too far away from the rest of the group. Now what happened? Well, this is where our sales guy Kurt has calculated the average. And what is the problem with average? Even if one of them is an extreme value, what will happen? It will give you a wrong picture. So what do? That is where we could use something like median. If we were to calculate median, it would be much more realistic is what we are saying here. Why? Median is less susceptible to influence of outliers. In other words, median does not get impacted by these extreme values. So how does that work? Let's try to find that, guys. Take a look at this one. So here we go. In an ordered array, median is the middle number. In other words, the mantra of median is it is mid number. It is a midpoint. So if you have 1, 2, 3, 4, 5, here is a midpoint. It is going by the position. If you have even one of the values is extreme, what it is doing is it is figuring out where is the mid value. That is becoming the median. So as a result of that, it does not get affected by the extreme values. If there are extreme values, or mathematically we call them as outliers, statistically, what will happen? We use median rather than mean. So in other words, let's go one step ahead. Take a look at this. How do we calculate the median? Okay, first arrange the values. First arrange the values in numerical order, smallest to largest, which means you sort them. Okay, median position is this position where n is the total number of points. If the number of values is odd, median is a middle number. If the number of values is even, you take the two mid numbers and then you take the average of that. Okay, so what does that mean? Take a look at this. 1, 2, 3, 4, 5. We have 5 numbers which are odd numbers, right? So come here, put this here, there. So what do you do? Pick up the mid number, that is the median. As simple as that. But if you have even numbers of points, what do? You pick up the two mid numbers and then you take the average of them. That becomes 3.5. That is if you have even number. So what is that? That's how you calculate the median. So the condition, one more time. For odd, pick up the mid number. For even, pick up the two mid numbers, then take the average. That is what is happening. And prior to calculating the median, here is another condition, guys, or here is the first condition that to be kept in mind. So notice, here are a group of numbers. What are we doing? You sort them. If you don't sort them, you may end up adding these two. If you sort them, you may end up adding these two. So if you don't sort them, this will give you a wrong picture. So you make sure you sort them, and that will give you the right median value. You need to sort it from smallest to largest, guys. Let's see what else we have. And gentlemen, ladies, everybody understood the median? Okay, thank you, guys. So the next one is mode, a much more simple one. Let's say come here. Mode is just the most frequently occurring item. So among all these things, mode, that is number which is appearing 3 times, so that becomes a mode. In here, none of them are repeating. There is nothing like everything is appearing one time, so we call that there is no mode. You can have no mode, you can have several modes. That's what that means, guys. These are, again, we may have touched them in school and things like that. Notice 2, 2, 2. 2 to 2 is appearing, 2 is appearing 3 times, so that is a mode. Take a look at this one. 2 and 3 are appearing 2 times, so that it's called bimodal. And if you have 3 numbers, more than 2, it is called multimodal. There are 3 numbers which are appearing 2 times. That's multimodal, guys. So now, let's take an example. So here's maybe a slightly confusing example, guys. Let's take Prasad. Prasad is one of our attendees. He's a real estate agent and he's sitting in an office of a real estate. He's selling houses. What does he have? These are the group of houses he has. He has houses ranging from $120,000 to $2 million. Now what do? Lots of customers are coming into the office. They're inquiring, hey, what are the houses and things like that. So let's say, imagine Prasad starts using me. He's telling everybody we have houses, their average is $500,000. What can happen, guys? If somebody is only able to pay 120, 130, 300, what will happen? All these customers with that number, they will leave. They will not enter your office. So what is the problem? Well, that's a problem. You don't want to lose any customers, guys. Let's say we took the median. What is median? Median will come somewhere in the center, the midpoint. So in other words, more precisely, I think it is taking the average of these two. Let me do a little bit of cleanup. So median is nothing but it's picking up this point, that is becoming the median. If you say your average based on the median, the guys who are interested in $1 million houses will not even come. The guys who are in at $500,000 will not come. So the rich customers will not come if you use median. There is no mode here. So now here's a slightly tough question in a friendly way, guys. What do you think is the correct way to give a picture? Let's see, lots of medians, lots of modes. So in other words, just because we know mean, median and mode, we don't need to go by that one. We don't need to use them. We can say we have houses ranging anywhere from $120,000 to $2 million. That is called the range. We have to go by that one so that we don't lose these customers, we don't lose these customers, so we don't lose these customers. Everybody with me, guys? Quick yes, please. That is called the range. Is it the variance? It is kind of it is a similar one to variance only, guys. Okay. So now What is that, guys? That's a touch of some of the basic statistical concepts back in school also you might have come across and things like that. But let's come to a little bit real world. We have briefly discussed king and queen together make a life. What's happening is here is king, queen and life together. There is a distance between king and queen. King and queen are together, life is slightly far away. So what is that? That is something what data scientists do. What do? They use the algorithms. They use natural language processing techniques, and the NLP techniques are giving this kind of things. What do? We try to make sense. What is king minus man plus woman, guys? We briefly discussed. What is king to a queen is man to a woman. King is a man, queen is a woman. How you tell that is up to you. How you interpret is up to you. What is this? This is what the languages are indicating. Languages give you patterns like this, and we try to tell a story about that. King and queen together make a life. What is king? What is king to a queen is man to a woman is also can be said that, guys. So what is that? That is based on that we can say Sachin Tendulkar is the Roger Federer of the cricket. What do machines indicate? Machines are indicating Roger Federer minus tennis plus cricket equals to Sachin Tendulkar. Based on this one, we are able to understand. You may think this is a simple example, guys. When you apply this kind of concepts in a healthcare or a telecom world, what's happening is some very, very interesting patterns are being found out. Based on, think of Roger Federer, tennis and cricket are medicine names, medicine and a disease. So in other words, let's say, for the sake of simplicity, I'll go a little bit deep into it. Let's see if it helps you. For the sake, so that you will understand, I'm using Roger Federer. Oh, come here. I'm using Roger Federer, I'm using Sachin Tendulkar, I'm using tennis and cricket. But imagine you take a lot of healthcare data. Let's say this is medicine 1, this is medicine 2. Let's say this is disease 1, let's say this is disease 2. What can happen now? If you take a lot of healthcare data, we are saying, hey, if this guy, so let's say Sachin Tendulkar is Roger Federer of the cricket, means we can indirectly come and interpret that this medicine may end up working for this kind of a disease is what we may be able to find out. That may not be a very, very precise example, but that kind of patterns is generally what data scientists do. We try to find hidden patterns like that. Everybody with me, guys? Quick yes, please. Okay, not a very great example, but just trying to give you. So take a look at this, guys. Imagine a couple of boys. They're trying to cross the street. What is happening? Here is what is happening. The first thing you do when you're attempting to cross the road, you look left, you look right. So based on, your road conditions, rules and things like that, you start looking left and right. You take a look at the vehicles on the road and you try to make a decision. Without us knowing, our brain is at work. Our brain is doing a lot of work trying to make a decision. Our brain is able to analyze in a matter of milliseconds what kind of vehicles is coming towards us. Can machines do that? Okay, what is that? That is what is computer vision. So what is computer vision, guys? Computer vision is changing the game. We can build a computer vision models that can detect objects, determine the shape, predict the direction of the objects will go, and many other things. That is what the driverless cars is about. That's a very, very powerful technology which is being looked into, which is being investigated and things like that, guys. The computer vision is coming to our rescue. So take a look at this. Here is Nadia. Nadia is a Nobel Prize winner. What is this one, guys? This is what is called as face detection. What can we do? We can also detect her eyes. These are the concepts that are being used in a driverless AI cars, guys. Take a look at this. There is one guy who's a very, very big guy here. Let's see if anybody can recognize him. Can anybody recognize the great man here in this picture? Aristotle. Okay, lots of Einsteins coming up. So take a look at this. What is that? This is what data scientists do. We are writing programs which are solving this kind of problems. There's a lot of people. We want to first detect their faces. That is the first step. Then, who's Albert Einstein, guys? So take a look at this guy. So come here. Choose this one. Here's Albert Einstein. Now, can any one of you take a guess what is the problem in this picture, guys? In this picture, there's a problem. Can any one of you? It is old, it is blur. Okay, it is, there you go. One face is not getting detected. Take a look at that guy. What do we do? These are the kind of problems that data scientists solve. There's a lot of guys, for some reason, the side face is not getting detected. In your real world projects, what will happen? You'll be given projects like this. This is what data scientists do. I'm trying to give you a feel of the kind of programs that you generally work on, guys. So let's come here. Take a look at this one. Now take a look at this, guys. This is Russian roads. Lots of cars traveling on a fine evening, on an evening time and things like that. Now what is this? This is detecting the nameplate, the number plate. What are we doing? We are blurring it. What do we do? This is what data scientists do. We try to identify. Here we are blurring a number plate, but you may want to blur some content which is very sensitive to certain people and things like that. What is that? That is what data scientists do. Why is that important? That's what companies need. Companies need the people who have this kind of knowledge, who have this kind of skills, guys. That is what companies are looking for. It is not just important what you can do. It is also important what is needed, what is the requirement. If they're looking for cricketers and you're learning football, then you better learn cricket. Football is a great game, but cricket is where is the requirement, guys. Everybody with me, guys? Quick yes, please. Okay, good. Now take a look at this, guys. Let's go a little bit deep. We can build a dog and a cat classifier to detect and predict that. Okay, so we have a dog here, a dog and a cat here. What can we do? We solve problems like this. We try to detect which is a cat versus which is a dog. We won't know the location. Detection is where you're trying to identify which is a cat versus which is a dog. So image localization means it helps us to identify the location of a single object. So here, this rectangle is telling you the object is located here. That is called localization. You're locating the object. In case we have multiple objects, what do? We detect it. That is called object detection, is what it is. Generally, we use the deep learning techniques. These are some more advanced scenarios. The image processing techniques and things like that are advanced scenarios. That's where deep learning comes to your rescue, guys. So another one here, take a look at this, object detection. Object detection builds a bounding box corresponding to each class in the image. Okay, so detection is you're just detecting, but it tells us nothing about the shape of the object. We only get the bounding box. It just says, hey, here's a rectangle, red rectangle, green one, and a blue one. It's giving you. But here comes a slightly more advanced technique. Image segmentation creates a pixel-wise mask for each object in the image. So this is called a mask. A red mask, a green mask, and a blue mask. What is this? That is called segmentation. This technique gives us a far more granular understanding of the object. In what way is that helpful, guys? Let's go one step ahead. Take a look at this. So here's cancer, and we all know cancer. What are these? These are cancerous cells. What's cancer, guys? What's special about this cancer? I think, according to my understanding, what happens, guys, in our body when somebody has cancer, these cells start growing exponentially. They should be growing at a certain rate, but these will be growing at an exponential rate. What is that? That's the problem. That's why it's called a deadly illness. In today's age of technological advancements, cancer can be very fatal if we don't identify at an early stage, which means if you're able to identify at an early stage, you can take care of it, but otherwise it's out of control. Detecting cancerous cells quickly as possible can potentially save millions of lives. It can save millions of lives if we are somehow able to identify cancerous cells in the body. The shape of the cells plays a vital role. What is important? We can use the techniques of object detection and segmentation and try to identify the shapes. When we are able to identify the shapes, what can you do? Based on the shape, you can generate the data. And what can you do? You can take the data and give it to an algorithm. And what will happen? That algorithm will act like a model, will give you a model. That model can predict whether something is a cancerous cell or whether something is not a cancerous cell. That is not just very useful, that is super useful. Why? That can save millions of lives. Everybody with me, guys? Quick yes, please. Okay, so in real world, that is what a lot of companies are working, businesses are working. So the people who are into the world of data science, artificial intelligence, and things like that, these are the kind of things they do, guys. Computer vision techniques make a massive impact here. They are being used in traffic control systems, self-driving cars, locating objects in satellite images and things like that. These are very, very cool things to work on. That is why they are called, data scientist is called the sexiest job of the 21st century. Never in the history of mankind a job was called as a sexy job, but a data scientist is referred as the sexiest job of the 21st century because you work on such cool things. Okay, guys, the driverless cars, if you do not use the concepts of computer vision, you take out machine learning and deep learning, it is not a reality. It cannot be a reality without these things, guys. So these are the techniques which are making them a reality. Now, before I go into these things, okay, take a look at this one. This is a very, very sophisticated, mass car CNN is a very, very sophisticated way, is a model which detects different kinds of cars and things like that. But take a look at this one. For a moment, what I'm going to do, I'm going to run this. I'm not sure if you're able to hear the voice of the cars. But let's give it a moment. Cool. So I don't know if you heard the voice there and things like that. But what is going on, guys? Lots of cars are going. What can you do? We can use the techniques of computer vision. We can identify at which point, at what time, how many bikes, how many cars went on. And then what can you do? You can generate visualizations like that. Take a look at this one. Between 9 a.m. and 3 p.m. Okay, what's happening? That's the total number of cars, total number of trucks, total number of buses, total number of bikes. Which one? It looks like lots of cars followed by trucks are going on this highway. Okay, now in what way is this information, visualization is useful to people in a daily life? Well, the transportation department, the police department can have a look at this, can take, and what can they do? They can understand that lots of cars are going here. This is one highway. So they can do some planning. Maybe there are some highways, maybe there are some roads where there are more bikes, more buses. What can they do? They can do the planning based on this one. Take a look at this one. This is between 9 a.m. to 10 a.m. So what's happening? On a hourly by hourly basis, sometimes there are more cars, sometimes there are more trucks, sometimes there are more buses, more bikes. A lot of planning can be done based on this one. You can try to find where there are unusual number of cars, during unusual times and things like that. What is it? That is what data scientists do. Everybody getting an idea, guys? Can you give me a quick yes? Okay, so now what I'll do is, let's say, come back here. Before I take you into that one, let me see if I can open this one. This is called Jupyter. Tomorrow I'll try to give you a brief introduction about this one, but let me run a few things here which are related to computer vision, just so that you have a feel of it, guys. I'm not going to explain you the code line by line, but let's see. I'm going to run this one. Give it a moment. Let's wait for that. It's running. Let's see. I hope you're able to see the screen, guys, the Jupyter screen. Can you give me a quick yes if you're able to see that? One more time, can you quickly give a yes? Okay, you're able to see that, and let's see what's happening. Oh, something went wrong here. Let me come down here, scroll down here, display. So that means it's probably, I need to adjust mine. Let me try running it one more time. Run this, give it a moment. It's not catching it. I adjust my camera one more time. It should be able to catch it. Generally runs it. Oh, I'm thinking it is because of the air meet. Maybe it is giving me an issue. Okay. I think that is also taking care of my video camera. Let me try this one, guys. Let me run this one. See if this works. I think it is because OpenCV and it's complaining about error. Interesting. Just one more time for the sake of discipline. Should run. Not sure if AirMeet is making the problem. I think so, guys. And what's happening is the AirMeet video, even though it is not on, Start kernel again. Okay, not a good suggestion there. Let me refresh this one. Thank you, buddy. Who's that? That is Miriala Chand. Okay, let's refresh that. And let's give it another try. Give it a moment. Run this. And that's all. Okay. I'll be sharing this code towards the end, guys. When I cover the computer vision concepts. No, not much luck today. Bad, guys. That would have been nice. I'm thinking it is because try this one simple one here. Source is empty. It is not catching me. My video cam is not. Let me stop sharing. I can't stop sharing. If I stop sharing, you cannot. So it's complaining that it is empty. Size is assertion. What that means? I'm thinking it is because of AirMeet. Generally, when we connect in Zoom, I don't have this issue, guys. It's probably hijacking my webcam is what I'm thinking. It's hijacking my cam. Okay, never mind, guys. We'll try to switch on to Zoom in the coming up days. Kernel restart. Not you have to run the cells consecutively. That is true. In AirMeet. In AirMeet, I think Sandeep or somebody is telling stop the cam. Switch on the video cam. I don't need to. It will automatically open it, guys. And my AirMeet video cam is automatically off. It is in an off condition. Top left lock button. Let me see, guys. Sorry about that. Never tried this earlier. But in Zoom it works, guys. So I'm going to turn on the video. This is actually me, guys. I'm just saying hello and things. So this is AirMeet one. But what I'm trying to show you is the computer vision one. Let's see if I can move this one. Block the camera access to AirMeet. Let me see if I can find that in one moment. Kalyan Charlie. Good one, buddy. But I blocked it, buddy. I'm still getting it. That's what I'm wondering why. It's not for settings. Open cam in AirMeet and run. Open cam in AirMeet and run. Okay, let me. Okay. How about this, guys? I'm going to open this one. That's a good suggestion. Let me give one more try. So we'll try a simple example. Let's run that one. See if that helps. Shoot. It still doesn't run, guys. It's not catching. The size is coming to be empty means the frame is not getting. The webcam is getting hijacked by AirMeet. I'm still thinking it is hijacking it. Run from first cell. Not necessarily, but okay. For your satisfaction. Run this one. Run this one. Give it a moment. Bring this up. Okay. So AirMeet indirectly. Okay, let me not waste too much of time on this one. I'll see if I can. You're just turning off the video, but access is still in control. That is right. Sai. That is right, buddy. So I just need to figure out. Generally in Zoom, it doesn't give you this problem, but here it is giving you the problem. I'll try to figure it out tomorrow so that I don't waste your time, guys. I'll try to cam permission to AirMeet in settings. Let's say turn on video. Close that. Okay, one last try. Block cam in AirMeet. One last try. Okay, for sake of discipline, we'll run this. And let's see what happens now. I guess the hijacking is going on. I'll see if I can figure it out tomorrow, guys. I don't want to waste most of your time. So my apologies about that. I never worked on AirMeet, but we'll see if we can hook up Zoom. But let's see if we can make a little bit more use of our time, keep our time a little productive, guys. We still have a few minutes here. And everybody with me, guys? Can you give me a quick yes? Sorry about that. Right top block camera in search bar top right camera option. Search bar top right camera option. I don't see what you're saying, buddy. Top left lock symbol. Top left locks. Okay. Let's take it easy, guys. We'll try to see if we can use it on Zoom, and we'll make it easy. Let's not spend time on this. But I appreciate some of the suggestions. That is true sportsmanship. Keep it up. So let's make a little progress, guys. I'm going to bore you with a little bit of more theory. Let's see if that will help you in a little bit. So what is analytics, guys? Analytics is, in short and sweet, you have data, and come here. From data, you try to find intelligence, and you're trying to use that intelligence. That is also called insight. Insight is nothing but the knowledge. What do? We transform the data. From data, we try to find the insight. Understand the past. You understand the past, you understand the current, and you try to predict the future. Imagine you take stocks. What are you doing? You try to take a look at the stocks yesterday. You see how it is performing today, and then you try to make a prediction today. We understand the relations, the patterns, and translate them into meaningful and useful, relevant business insights and intelligent strategies, guys. What does that mean? We more precisely try to understand the hidden relations and hidden patterns. Imagine we have a group of people saying who's male, who's female. You can look at them, or you can look at their name and say they are male, they are female. But being able to identify that there are a group of people where they have a 100% chance or a probability of getting COVID. What is that? That is not easy to find. Being able to identify there's another group of people where, choose this one, there's another group of people where they have a 66% chance of probability. 66% probability that they will get COVID. It's not easy to find. What is that? Those are hidden patterns. And what is that? If you know somebody has a 100% chance versus somebody has a 66% chance or a probability of getting affected with COVID, what can we do? We can make some decisions. What are we doing? Based on the data, we are making decisions. That is called data-driven decision making. What's happening? Every business today is trying to do that. What's the problem? Not a lot of people know these techniques. Okay, everybody okay with this slide, guys? Quick yes. Okay, so now, so analytics is like a general term. Here is business intelligence, guys. Let's see what is business intelligence. Business intelligence implies transformation of data to generate meaningful, relevant, actionable intelligence. In other words, that is also similar to analytics. Business intelligence is applying analytics on databases and large databases, which are referred as data warehouses. But there's a subtle, if you go a little bit deep into it, business intelligence is trying to understand what happened. What is the status of the business? So in other words, imagine, okay, we'll see that. And we will also, so in other words, ideally, in a world of business intelligence, you have business analysts. What do? They generate different kinds of reports, and they're trying to understand what is happening in the business. Something happened. They try to understand what happened. Is this happening many times, or is this happening only sometimes? That is what they try to understand. So if that is a problem, why? What is the problem? What exactly is the problem? What is the problem which is causing this problem? Is what they'll try to understand. So what do we do? How do we take care of that problem is what they will do. This is where the key performance indicators come in. So take a look at this. Here is an example. We briefly talked about a Vanity Cosmetics Beauty Care product company, guys. What is happening? They are selling lots of beauty care products. So from Toronto, they're a Canadian-based company. These are all the different cities. And here is the sales in thousands of dollars. Here is the percentage of the sales. What's happening? This is something which already happened. So it happened and we are now looking at it. So in other words, we are looking at the past. And notice there's a green. There's a green means revenues, we met the target. But notice expenses is orange. Orange means we did not meet the target. Profits, we met the target. But notice this is market share. We did not meet the target. It's giving you a warning. What is this? This is something which has already happened. What is it? You generate a report and you try to understand this thing, what that is business intelligence. Business intelligence focuses more on the past. Okay, so if you're driving a car, you're looking back. How do you look back? You look at the rear view mirror. That's what business intelligence is. So come here, take a look at this. Okay. So, okay, that is a quick touch of business intelligence. Everybody with me, guys. Before I explain you a little further. Okay. And okay, let's move a little ahead. So let's see what we have here, guys. So one more time, another example which says, thank you all so very much. Thank you to the Academy. Thank you to all of you in this room. I have to congratulate the other incredible nominees this year. The Revenant was the product of the tireless efforts of an unbelievable cast and crew. What is this, guys? This is like a award ceremony speech. It is generally referred as unstructured data or textual data. What can we do? Take a look at this. We have about a few lines. We are separating all the lines. There are roughly about 5 lines here. What are we doing here? We're converting everything to lowercase. This is called preprocessing. Then what do? Imagine we are taking each word and we are counting how many times each word is appearing. The word the is appearing the maximum number of times. So what do? Now you take every word and divide by the maximum number of times the word the is appearing. Well, this is what you get. This is called weighting. Okay. So in other words, these are a group of mathematical steps we are performing on unstructured data, textual data. What is this? This is the first line. Thank you all so very much. If you add all the weights, you get that number. What do? You do that for every line. Then what do? You sort them. Then what do? You take the top 2. What do you have? You have this one. The Revenant was the product of the tireless efforts of an unbelievable cast and crew. Thank you to all of you in this room. What is this? This is called text summarization. Okay. Instead of reading 5 lines in 2 lines by using a few mathematical principles or mathematical concepts, we have arrived at a summary. What is that? That is what data scientists do. Another example of what we generally do in organizations, guys. Everybody with me? So what do? So here's what we do. Here's a data scientist. We find patterns. What is this? We find hidden patterns. The pattern is coming on the left-hand side if you notice here. That's what we do. What are we doing? We are using a touch of statistics. We use some principles of statistics, some principles of programming, which in the coming up days, I will explain you from basics. We use a few data concepts, a lot of machine learning concepts and modeling concepts. And then we try to understand the knowledge. That is what we do as data scientists. Okay, guys, what is happening? World is changing fast. Data is at the heart of the change. That's why data scientist is called the profession of the future. Everybody with me, guys? Quick yes, please. Cool. So that is just to give you an idea. Hey, these are some more techniques that you will be working as. Tomorrow, if you become a data scientist, an AI professional, these are the kind of things that they will ask you to be working on. That is why it is one of the most liked job of the century is what it is and things like that. And let's see. Okay, gentlemen, there comes the buzzword artificial intelligence. We have a few minutes here. I will take a few slides and then I'll leave the platform to a few questions. So AI is the new electricity. Artificial intelligence is the new electricity. We've been talking about data science. Let's also get a perspective of what is artificial intelligence, guys. So what's happening? AI is everywhere. What does that mean? Electricity is everywhere. We cannot imagine without electricity. We can still live, but things will be very, very slow. And today we are all trying to be very productive. That's why we use electricity. We use a lot of many other things and so on, guys. We just cannot imagine without electricity, right? So AI is becoming like that. About 100 years back, electricity transformed every major industry. In other words, if you go back 100 years back, nobody was using electricity. When electricity was invented, what happened? It transformed, it revolutionized the industries. Everybody started using electricity, the productivity went up, and lots of development, lots of industrialization happened. The exactly same thing. Today, not a lot of companies are into AI. Hardly any companies are into AI. It's only at the beginning. What's happening? Tomorrow, everybody is going to be using AI. We don't know, but we are already using AI in many ways, is what is happening, guys. AI has advanced to the point where it has the power to transform every major every major sector in the coming years. In other words, that is what we mean by AI is going to be everywhere, guys. Okay. What is artificial intelligence? Artificial intelligence is, or more precisely, AI is like cricket is a simple definition. Machine learning is the heart of artificial intelligence. Today, artificial intelligence is really machine learning plus, the hardware part of it, which is the robotics and things like that. But today, when anybody talks about artificial intelligence, they don't talk about the robotics. That's a separate thing. Most of them refer to the heart of AI, which is machine learning. And the heart of machine learning is deep learning. Machine learning and deep learning are nothing but a group of algorithms and advanced algorithms. Today, when people are talking, they are referring to the machine learning and deep learning, guys. So, in a slightly friendly way, I'll explain it like this. If AI is like cricket, machine learning is learning how to hit the fours. Deep learning is learning how to hit the sixes. Learning, if you're taking singles in cricket, it's good. But when you hit fours, what happens? Everybody get up. Everybody get up and we are all thrilled, we're all excited, we're all happy and things like that. That's what machine learning does. Okay? What is that? That's at a slightly friendly level, at a simplistic level. But here is what is happening in the next 5 years, guys. In the next 5 years, if you're an underwriter, bank teller, accountants, taxi drivers, your job is going to be gone. Pardon me. In the next 10 years, if you're a financial analyst, construction worker, or a farmer, your job is going to be gone. Okay? What's that? Why is that? The AI is going to be taking the jobs of all these guys. And now, what do we have here? Take a look at this. University of Nottingham researchers created an AI system that scanned routine medical data to predict which patients would have strokes or heart attacks within the next 10 years. In other words, they have created an AI system. It is identifying in the next 2 years who is going to get a heart attack. Imagine if we are going to predict who is going to get heart attack in the next 10 years. Is that good or is that bad, guys? Is that good or bad? You're saying yes. Huh? Okay, I think you mean it is good. I don't think anybody will say it's bad. But gentlemen, ladies, that is super good. Imagine in the next 10 years, we identified a few people. What will happen? Well, if we know that somebody is going to get a heart attack, what do healthcare organizations do? They can call them. They can tell them, hey buddy, your data is indicating you're going to get a heart attack. So what can we do? We can take the necessary precautions and measures. Right, guys? And if all the patients start taking the necessary measures and precautions, and if nobody is going to get a heart attack, is it good or bad, guys? That is good. That's a simple question. But the tough question is, if nobody is going to get heart attack, what is the problem with that, guys? Can you take a guess? There is a problem with that. All the doctors who are into the heart specialization, they will lose their jobs, right? True or not true? Okay, so what is that? That is not. So in other words, what is happening is, today, what the University of Nottingham is doing is, they are developing an AI system. It is not only applicable to heart attacks, but for every disease that is on earth. They are trying to use the data and trying to predict different kinds of diseases that people can get in the next 10 years. This is something that humans can have never thought of. It is not only not thought of, but it was unimaginable for something like humans. Humans can never think. If nobody is going to get any disease, what will happen, guys? Don't you think world will become a much more peaceful, much more better place? Don't you think so? Yes or no? Okay. So if nobody is going to have a health problem, what is that? That's a great thing, guys. What is that? That is what is artificial intelligence. Artificial intelligence is not coming in to take your jobs. Many people today are worried that artificial intelligence is going to be taking the jobs and things like that. What is going to happen is doctors are not going to lose their jobs. Can you imagine a doctor looking at 1 million or 10 million patients and trying to understand who is going to get a heart attack or not? Well, that is unimaginable. What is that? That is what AI is about. AI is not necessarily coming in to steal your jobs. AI is coming in to make the world better. What is going to happen is doctors are not going to lose their jobs. Doctors are going to be learning artificial intelligence, and they will work with patients using artificial intelligence. Whether it is doctors, whether it is mechanics, whether you are in any job, what are they going in? Everybody is going to be learning AI. That is what is going to happen. Even if you're a teacher, you're going to use AI and you're going to be teaching in the coming up days. It is not coming in to take your jobs. It is coming in to make the world better. Everybody with me, guys? Quick yes, please. Good, cool. So now take a look at this one. If you take a look at this one, this is the eye of a patient. You're using a very sophisticated machine. Imagine an eye doctor or an eye physician. Okay, he's looking at a very sophisticated machine and looking at the patient of an eye. What is happening? Here's what is happening. Machines, it seems a human doctor can, when they use these sophisticated machines and look at the eyes, they can detect about 2 to 3 diseases. Give it to machine, have it use machine learning, have it use deep learning, it is capable of detecting up to 50 diseases in the eye. Is that good? Is that good or not, guys? That is absolutely good. That is super good. Okay, what is that? That is the power of AI. Okay, and let's see, come here. Okay, so what I'm going to do is I'm going to stop these examples here. A little bit of theory here. Let me save it for tomorrow. And gentlemen, ladies, it's time for some questions. By presenting the tarot. Acha, I see. Pressing the tarot. There you go. Refresh button right side and left side to the URL block. You had lock symbol button. Click it, select block camera. Acha, Hemant. Good buddy, you're trying to help me. I think I need a little bit of time, buddy. These chats are going very, very fast here. I'm not able to read them. Does text summarization come under deep learning? Okay, it is more of a natural language processing, buddy. Who's that? Meghna, it's a natural language processing. It is not precisely deep learning. That's what that is. Refresh button right side and left side to URL. Heyman, thank you, buddy. Now camera connection with AirMeet stops. Click it, selected block camera. Oh boy. I don't see any refresh button here. But Hemant, we'll try to address it in another way, buddy. And let's see what else. What are the other questions? Instead of gray. Hope theory is done. Okay. I see Miriala Chand. It says, no more theory. Notebook next to bookmark symbol. And that is Sai. Acha, I see. Let me see. This page is accessing your camera and microphone. I see what you mean. So let's say always block camera and microphone. Okay, let me stop this. Camera and microphone. No, microphone I want it. Camera is integrated. Microphone, let's say manage this. Let's see what comes up. AirMeet, recent activity. Oh, come back here. One more time. always block. Let's say done. Can you see my screen, guys? Are you able to see my screen? Can you hear me? Could you quickly give me a yes? Oh, say, go ahead.
We can hear you, sir, but we can't see.
Okay, let me come back here. Go here. Let me try this one now. Oh, there you go, guys. Gentlemen, ladies, let's see. The chat
Sir,
is...
we cannot see your screen.
You cannot see my screen. If I block the camera, this is gone. Let me try one more time. I'll share the screen. One moment. Select this. Let's say your entire screen. Share it. Can you see it now? Mansa, is that you? Can you see my screen, guys? Okay, there's me, guys, gentlemen, ladies.
Yes, sir, we can.
I hope you're seeing me. And that is using computer vision, guys. Sorry about that. So thank you. I think Hemant, Sai, thank you, guys. I appreciate it. You're true sportsman, sportsmanship spirit. Keep it up. Very good. You're helping others. That is very, very important, guys. Whether you're a data scientist, AI professional, that is very, very important. Always keep that in the mind. Just a friendly preaching there. I don't mean to preach you, but that is just me. I'm just trying to show you some computer vision concepts, guys. So now what I'm going to do, I'm going to close this one, quit this one. And what I wanted to show you guys, let's try this one now. One more time. Take a look at this. We'll run this. Wait a moment. Stunning gentlemen, ladies. One more time. That's me in black, color. Okay, guys. Okay. Hope I just wanted to show myself using the computer vision. I'll give you a touch of these things in the coming up days. But let's see what we have. Take a look at this. Wait a moment. This is Jupyter Notebook. We all should say thanks to Sai and who's the other guy? Hemant, guys. Okay. So now notice this, guys. This is called static drawing. So what happened here is, now notice this. I'm going to move here. I'm going to move a little bit here. I'm moving a little bit here, a little bit here. And notice the rectangle doesn't move. You take your smartphone camera and you try to move and notice it, the rectangle moves. It's detecting. So right now it is not really detecting. Okay, guys. So this is called static drawing, guys. I'm going to quit this. Let's say go to the next one. Now here is, let's run this one. Draw rectangle. Give it a moment. There you go. So let's see what happens now. Now I'm going to click here. I'm going to click here. And now I'm going to move. I'm moving. Notice the rectangle doesn't move. Okay, it's still there. So what is this? This is like, you're drawing it dynamically, but the rectangle is still not catching my, it's not really detecting me. That's what is happening here, guys. Let's try another one. Let's see how this one works. Some issue here. Source is empty. Strange. Oh, there you go. Catches it. Now notice that, guys. It came up. It did give me an error message. But let's see. Let me adjust my video cam. And let's see. So there's a Baba's picture. For a moment, it looked like, let me come a little bit close. It's not catching me. I think it's because of this, guys. I'm going to take off this one. Hey, catch me. It's giving me a slightly tough time. I think it's because of the lighting. One moment. Okay, how about now, guys? There you go, guys. The lighting has been causing some issue. Now notice I come close. It's catching my eye. What's that? That's your smartphone. That's a touch of computer vision, guys. Okay. So in other words, your smartphones and things like that are really using the concepts of computer vision and models like that. I'm gonna close that. And what will we do, guys? This is what we do as data scientists. Oh, sorry about that. So if you notice, guys, these are the things. What I was trying to convey was these are the things that we data scientists work on. These are the problems that we work on. Sometimes it catches the face, sometimes it detects the face, it doesn't detect the face and things like that. And what do? Those are the projects that you generally work on. Detecting unknown sources. That could be a face, that could be a cat, that could be a dog, that could be anything else. So I will try to give you a decent introduction in the coming up days. And the files and code, give a little bit of time for me, Sai. Towards the end, we'll definitely share it, but give us a little bit of time. We're still in the process of finalizing them, buddy. Repeated questions in the feedback form. I see. Feedback is for Manasa. She will be taking care of that. The jobs are almost coming in the next 10 years. Which jobs are coming in the next 10 years? Those are the jobs which are going to be lost in the next 10 years. Not coming up, but let's say, come here. Where is that one? Here's the AP skill. I think this is what you're requesting. Somebody wanted me to show this screen. In the next 10 years, AI is going to take them, guys. More precisely, AI is not going to take them, but these guys will have to learn how to work with AI. They will have to learn a little bit of these concepts and try to do their jobs and works. That is what is going to happen, guys, in the coming up days. Face detection code, that's a simple one, guys. You should be able to find it pretty easily anywhere. So don't worry about that, Ashu. But I will be sharing it in the coming up days. Just give me a little time. We are trying to finalize some of this stuff. Books, data science from scratch is one book. Hands-on machine learning is another book. From O'Reilly, I think it is Oreilly, O'Reilly Publications, guys. Santosh. Which tools? If you learn Python, that is one of the best ones, Santosh. For data analyst, for a data scientist, for AI, everybody is into Python today. No, Java, .NET is not necessary. Python is more preferable. And let's see where we are. Data analysts don't do predictive analytics. Data scientists also do predictive analytics. If you take out the predictive analytics part of it, then that is data analysis. Data analyst, that's what data analysts do. O'Reilly, there you go. Hands-on machine learning from Kranti. Good buddy. Thank you. You're a sportsman. There's a link from Kranti, guys, if you noticed. That's a good book to refer. So data science and AI. Data science we've been talking about. AI is generally, the people in AI do not do much of pre-processing. They are mostly into predictive analytics, machine learning and deep learning and the robotics. Data science also has the pre-processing part of it. Okay, so that is slightly at a high level, guys. Hands-on. I will show you some of the stuff. Okay, I turned off the video. Let me see. There is a video. Just say. Let's go back to the video. Continue the video. Okay, now I'm sharing my video one more time. This is not on the computer vision, but this is the AirMeet video. Let me try this. Continue. Let's do it down. Can you see me, guys? AI or data science, if you're into AI, you'll be into data science. If you're into data science, you'll be indirectly into AI only. Guys.
We can.
Acha. So something, I think. Okay. That's okay, guys. Don't worry about looking at me. I'm going to turn that off. Maybe tomorrow. Mansa, if it permits, please look into Zoom. Then Java. Java is, thank you, Mansa. So Java is not necessary, guys. One more time. Manage it from settings. And who's that? Somalia. Thank you, Somalia. I appreciate that, buddy. I'll try it tomorrow. Okay. So, gentlemen, ladies, did you find it helpful and useful today? Did it give you a slight idea and things like that? Okay, thank you guys. So what we'll do is we'll continue our journey tomorrow, and I will give you a slight touch of Python. If you have a little bit of time and if it permits, do a little bit of basic reading on the basics of Python, so that when I talk a little bit about Python, you're slightly familiar tomorrow, guys. You can Google is your friend. You start there, and in the coming up days, we'll share some of the stuff we are showing here. We will share it for sure, but just give us some time. Okay. So for today, R is a competitor of Python, but Python is a rock star. R is a superstar, but Python is a rock star. A superstar of superstar is Python. Okay, guys, everybody is by default into Python when they are into the world of AI and data science, guys. Very good. Keep it up. Thank you, guys. With that, I will sign off here for today. You guys take care, stay safe, keep learning, guys. Signing off for today. Thank you and bye for now. Thank you again, guys.
Thank
Thank you, Mansa.
So thank you everyone. So as per the requirement, if we have to change the platform, we'll send a mail to you. So please check your mails also daily, and we will share the feedback link at the end of the session. Regarding the PPTs, we will discuss with the resource person once, and I will let you know. Thank you.